Hello folks, how you guys are doing? Only two have joined till now, so I guess we can wait a little bit so that others can join and we can start doing today's program. So today we will be building recommendation system. Okay. Let me see how many of you have joined. 4. Not enough. Join. It's already 10 minutes past. Okay, so let's start. Then meanwhile others will be joining. Let me just give you a brief idea about what a recommendation system is, how we can build a recommendation system, and then we will be going to make a recommendation system of movies, right? Like we watch in Netflix and Amazon Prime and all other OTT platforms. So how the OTT platform recommendation system works, not exactly we will be copying that, but we will be having somewhat recommenders depending on the movies the user used to watch, right? So let's start. Recommendation system are of two broadly categorizing two types, right? The first one is content based. Let me just go with this one. And another is collaborative filtering. These are the two main type of recommendation system, two type of method of recommending certain things depending on what the behavior of the user or what is the behavior of the items, right? So how these two are different. Collaborative filtering is this is much this one collaborative filtering, it gives better result as compared to content based filtering. Okay, so we recommend system based on the content of that content means here the product. Okay, the product can be a movie, the product can be a purchase item, the product can be anything. So depending on the product, similar product can be recommended, or we can use collaborative filtering. So what is collaborative filtering? It actually takes, what I can say, the user and the item together to filter the similar kind of item to recommend the user. Okay, so if I to describe this, the content based recommendation system is like attribute of the item to recognize other items. So this one is attribute of one item, attributes, maybe several attributes of one item to recommend other item. Okay, so this is what content based recommendation system does. Okay, and collaborative filtering is attribute of the user towards the item to recommend other item. So this one is attribute of user towards an item to recommend other item. Okay, so based on this attribute of the user, it can be further classified into other categories. So there are two other classification of this, of collaborative filtering, that is memory based and model based. Okay, so this is the entire set of recommendation system. It can be recommend a product using the content or the attribute, similar attribute content. It can do this, or it can use the attribute of the user to recommend other items, similar items, and that can be further classified as a memory based or model based. Okay, collaborative filtering is largely used in different scenarios, but let me tell you, this collaborative filtering needs a heavy dose of linear algebra. Okay, to understand linear algebra, we need to discuss certain amount of linear algebra, or you need to have certain background on linear algebra to understand how this works. So what we will be doing, we will be building recommendation system for this course using content based. Okay, nevertheless, many of the leading industry still use content based system because of the type of application they are doing, but collaborative filtering overall gives better results. So this is a better performing recommendation system methodology, right? But today we will be going for the simple building first, and I will share the advanced one, collaborative filtering and how to use memory based and model based both. I will share with you. If you have adequate linear algebra background, you can go through that, and if you have any problem understanding that Python code, you can always reach to me. Okay, so what we will be doing, we will be building a recommendation system of movie. So what we will be doing, today's task is to recommend a movie based on a movie that I have watched. Okay, so let's say you have watched a movie, let's say what can be a movie? So you have recently watched give me a movie name. a good movie. Let's say Titanic, or let's say Uri. Okay, so if you have to watch Titanic, what recommendation based on this last watch can be recommended? Or if you have watched Uri, so based on that particular content, that particular item, what other recommendations can be watched? So this is an example of how recommendation system for content based works. Okay, so we will be seeing this thing. For this we'll be using a data set that is movie rating data set, right? So data for today will be movie rating data set. Okay, I will give you the link also, the movie rating data set, and for now we will be switching to the our coding Jupyter notebook. And another thing, if there is any there are some time left, we will like to go for decision tree and random forest also. Okay, if the time permits, we will cover decision tree and random forest, which was left yesterday. So let's see. First, let's make the recommendation system. Okay, so let's just first make the recommendation system, and then we will see what whether we have some time to cover decision tree or not. So let me just have a look how many of you are there. Okay, so without any further delay, let's jump to the coding. Okay, just a second, let me just switch my window for you. So yeah, let's switch. Yeah, perfect. So we will be having recommendation system of movie data set. This is the entire code that I will share you after this workshop. So I will build it from scratch. Okay, I will not dictating today. We have plenty of time to make this from scratch. So let's see how can we do. And later on I have this advanced recommendation system also, so you can go through it. Okay, so as you can see, it requires some amount of mathematics background and linear algebra, okay, to understand. This is a notebook which has everything explained. Okay, so I guess you won't have any issue. So model based collaborative filtering also explained. So I hope, and there are some more recommendation system and data sets where you can apply these models, or you can put your EDA or other what I can say, your imagination. You can put your imagination, modify the code, see what are the results coming. Okay, so there is always scope for modification. You can do that also. For now, we will be doing the simple one. Okay, so let me just open a new Python notebook. What is this? Python. An error occurred while creating new notebook. I guess I have. Fine. Okay, let's just, the first thing first, let's just import some libraries. So import numpy as np and import pandas as pd. Okay, now let's just give the column names. So column names is equals to user id. These are my columns: user id, item id, item id, rating, and timestamp. And let's just now read the data. Df is equals to pd dot data frame, sorry, read csv, my mistake. Read csv u dot data, and there will be a separation. As you see, the data has no extension .csv, so we need to if I am using the method read csv, I need to mention what is the separation. So separation here is tab, so it will create columns having if there is a separation of tab. Okay, so if every element separated using a tab will be put into different columns, separate columns, right? So that is what separation does. And the names, that is for the column names, is equals to column names, right? Okay, so let's just run this. Okay, df dot head, let's just see what happened. Okay, df dot head. So as you can see, this is my data, right? So it has user id, items, rating, what are the rating of the different item, and timestamp, at which time it was given. It is using a Unix time format, which is seconds after 1970, right? So I guess that is the 0th time second it Unix use as, and after that this many seconds has elapsed, so it can be converted. Okay, so we won't be dealing much with timestamp, so don't worry about this. Okay, so let's just import another CSV file that we have as movie titles. So the movie titles have in a different file. So this file was given in u.data. So we have another file that is movie id titles. Okay, so let's do that. Movie titles, let's just is equals to pd dot read csv. Okay, movie id titles, I guess. Okay, so let's just see now what is this data. Movie titles dot head. So this is the movie title. As you can see, these two data sets, df and movie titles, have same item id. So what we can do, we can just merge these two data set using this item id column, right? So let's just merge it and put it in df. So let's do that. Df is equals to df dot merge, right? Df comma movie id, movie titles, sorry, comma on using which column? Using item ID. Uh-oh. What is happening? What is happening? Oh, PD. Sorry. So pandas have a column method called merge. So using that, we are merging DF and movie titles, and we are merging on the column item ID. So let's just see now. df.head. Yeah, cool. So we have user ID, item ID, rating, timestamp, and the title of the movie. So now pretty much we have the data frame that we want to go ahead with. So before doing the recommendations, let's see some of the data. So EDA, exploratory data analysis and visualization. So for that we need to import matplotlib, right? matplotlib.pyplot as plt as usual. Then we will be importing seaborn as SNS. Okay, now let's just set sns.setStyle. You can set any style, but I will prefer white style. You can set white grid, you can say 395 or 365, something like that was also there. So whatever, you can see what other styles available. Okay, so now what we will do, we will group by the name and see what is the rating, okay, and what is the mean value of each individual title, what is the mean rating that they have. Like Star Wars, it has many Star Wars title, and every title has a rating. So I will group by a let's say Star Wars have, what is the mean value of the rating Star Wars has. Okay, so like that. So to do that, what we will do, I will do df dot group by, and I will pass the title column, right? So we are grouping by title, and then we will see the rating column. From that, it will be grouped. From that group, we will call the rating column, and we will perform mean operation on that column, because it has a numeric value. This title has a numeric value, we can see the mean. Okay, and then what we will be doing, we will be just sorting the values, sort values. So we will have some mean values, so with all those mean values will be sorted, mean values. And so let's say for title Star Wars, it has some mean value, for some other title it has some other mean value. So those mean value will vary, and then we will be sorting those mean value from highest to lowest. So ascending will be equals to false, so it will be in descending manner, right? So by default ascending is true, so we have to mention ascending equals to false. And let's just see this data. Okay, so for that head, so let's just run it. Okay, so what we see the title of the movies, and we see the rating of the movies. So these are the movies that has 5. So if I let's say, if I say 10, all okay, the top 5. If I just go to tail, let's say tail, what are the worst movie? These are the worst rated movies. Okay, mean value is 1. So if you see here, these movies, Santa with Muscles, Star Kid, Saint, Great Dane, Harlem. So these movies we have never heard of, right? So maybe it may have happened, only 1% or 2% have seen this movie and rated it as 5 star. So as a mean value, it will become 5. So it can happen, it is a possible case. So for that, let's see how many number of ratings we have for each title. Okay, so to do that, let's do the same thing. We will first group by the title, and let's see what is the count of the rating, how many counts of each title rating have, right? So let's do that. df dot group by title, and then we will call, from that group we will call the rating column. Okay, so it may have a certain number of ratings for different, let's say for Star Wars. Here this is the df, right? So I am grouping using Star Wars. So Star Wars, let's say, have this many columns, so this many ratings, so 1 2 3 4 5, so let's say 5. So if I call the title, group by the title, and see the rating, we will have 5 ratings for Star Wars. So that is what I am counting, so I will call the count. So let's say count, and then again I will sort those values from ascending, from highest to lowest, sort values. Okay, I will say ascending is equals to false, and then I will see the head. As you can see, these are the highest number of ratings. These movies has got highest number of ratings, not the highest ratings, number of ratings. Okay, so these many ratings. Star Wars have 584 ratings, number of ratings. Contact has 509 ratings. Fargo, Return of the Jedi, Liar. So these Star Wars and Return of the Jedi, if you are a Star Wars fan, you may have heard of this thing, heard of these movies, and other American movies if you follow Hollywood, maybe, because these are old movies, you may or may not heard of, but most likely you have heard Star Wars, right? So these two are Star Wars movie having one of the highest number of ratings. Okay, the count of ratings. Okay, so now we have number of ratings. So what we can do, we can add these, right? We can add these values, the mean values and the rating values, right? So let's do that. Let's create a data frame. Let's say ratings. Let's say ratings is equals to pd dot data frame, and then let's just do this. We have mean value. Okay, so we will have mean value, and let's see what is ratings dot head, how it looks like. So using those titles, so these title has this much of rating, this title has this much of rating. Okay, so if I do that, okay, so I have titles and their ratings, average ratings. Okay, now let's add a number of ratings also, this row also. So with this, every title we have the average rating and how many ratings, how many number of ratings we have. So let's do that also. So what we will be doing, so in this ratings data frame, I will be creating another column. Let's say number of ratings. Okay, so that will be equals to this thing here, this thing, the count, right? So let's just put it here. So it is a series, so we have to put it as a pd dot data frame, right? So we need to convert it into data frame and put that column into the ratings data frame, right? So let's see the ratings now. Ratings dot head, how it looks like. So now we have the title, that is our index. Now we have the rating of each title and number of ratings. So only 9 ratings has given to till there was you, that is a movie name. So far so good. So now we have a rating data frame. We have our original data frame. This is our original data frame. From that we have made this data frame. That is much more likely what we will be using for recommendations, right? So let's see. Let's do some plots also. So let's say I want to see the histogram of the rating. Okay, how these ratings are varying. Okay, so let's see that. So how many ratings are 1, how many ratings are 2, 3, 4, or something like that. What are the average rating histogram? So for that, plt.figure. Okay, so let's set the fixed size. Fixed size equals to, let's say 10,4. Okay, now we will be plotting. What we should plot? Let's first plot the this thing, the rating, right? Let's just see what is the what is the distribution of the rating. So for that we will call ratings dot ratings. From ratings we will call rating. It's somewhat similar. Ratings is the data frame, and rating is another column in that data frame, right? So we are calling this column, and we will be plotting hist. So dot hist, and I will use bins equals to 70 because it is a large data set. So we'll be using. So this is my plot. This is how it looks like. So 1 to 5 are the ratings, and this is how the data are distributed. So it has so many of data having a average value of 60, more than like 70 data have rated as 1, average value of 1, and 3 is the highest rated. So as you can see, there are spikes, and is in 1, 2, 3, 4, and some 5 also. These are most likely the hit movies, okay, or some movies that is watched one time, or rated by one person as 5. So the spikes here actually tells us that most of the users gives rating in whole number 1, 2, 3. So that's why the average spike in these whole number averages. Okay, nevertheless, this is the distribution of overall ratings. Now let's see what are the number of ratings we have. So for that, same thing, I will just copy and paste it here and just change the column. What will be my column now? Number of ratings. So I will call up this column, number of ratings, and let's see. So this is our number of ratings. So most of the most of the films have 0 to 5 number of reviews, right? So very less reviews. Most of the movies have very less reviews. That may be because the movies is not very good, not very popular. So these are the popular movies. These have more than 200 reviews, or more than 100 reviews, or such that. Okay, so this is a very basic visualization. So we can also use the joint plot to see how this is varying. SNS.joint plot. Okay, so for that we will be use X as, let's say, rating column, and Y is equals to number of ratings, and our data is equals to, what is my data? Data is equals to ratings, and let's just make alpha is equals to 0.5. Let's just plot that. So this is my distribution. Like if number of rating is high, then the average rating is likely to be less, right? There are although 5 ratings, there are although 1 ratings, okay, If the number of rating is low, then it is likely to be 5. Okay, because less number of people has rated, only 2 or 3 or 1 people rated a movie and rated it as 1 or as 5. So that's why those movies has 5 rating or 1 rating for that. So if the number of rating is low, it can have a high value also, so or lowest or highest values also. Okay, so this is the representation. This is a insight we can draw. If the rating goes high, a number of rating goes high, it is likely to be somewhere between. And if the movie is blockbuster, so if the number of rating is high, number of review is high, it may be shift towards the highest rating. So it is shifting. As you can see, the curve is shifting like this. It is a skewed curve, right? It is a skewed curve. Okay, so this is our joint plot. From that we can conclude this is the relation between number of rating and the actual average rating of a movie. Now let's make a table, right? So in that table, what we will have, in that table we will having the user who rated a movie. Okay, then we will have the title, and then we will have the actual rating, what he rated. Okay, so we will have every movie in that data frame as our column. Okay, and we will have index as our user. So it may be there are 150 movies, so we will have 150 columns, and we will have a user, let's say user 1, and we will put the user is rated every movie as how many stars, 1 star, 2 star, 3 star. If a user didn't rated every movie, whichever movie it is he or she has rated, it will be have some number like 1 2 3 4 5, and if he hasn't rated that movie, it will be a empty cell, NaN, not a number cell. Okay, so let's just do that. It is called a pivot table. Okay, so we will be creating a pivot table. So for that we need the user ID. So I will having the user ID from our df main data frame. It will have the title, so we converting user ID as our index and all the title as our column. So whatever title, Star Wars is a column. Okay, then let's say this movie is another column, and we will have every user ID, what rating it has given to other every movies. Okay, so let me just write the code and make you see what I mean. So let's see, that is by movie mat, that is a matrix or pivot table. So that is df dot pivot table. That is my index will be user ID. Okay, my columns will be the titles, and my values will be the ratings. Okay, so if I just run this, let's just see how it looks like. So movie mat dot head. So this is the matrix I am talking about. So user ID 0, it has rated till there, it didn't rate till there was U, so it is a NaN value. So there are lots of NaN values because the user didn't rated these movies. Okay, so it may have rated some other movies, like the user 1, it has rated this movie as 2, 12 Angry Men as 5, 20,000 Leagues Under the Sea as 3, and so on and so forth. And the other movies he didn't rate it, so these are NaNs. Okay, so now we will use this movie mat to recommend our movies. Okay, so how we will do that, we will see in a minute. So let's just do the thing. Let's call the ratings dot, that is our another data frame. See, this is, so I have 3 data frames right now. That is, one is our rating, another is let's just, for your reference, let's just print it, ratings dot head. Okay, let's pass print. Another is print df dot head, and print, and movie mat is there in previous cell, so I'm not printing it again. Okay, so as you can see, these are the other 2. This is one, the rating, and this is another, okay. So this is my df, the actual data, this is my rating that I formed, and this is another data that I formed, movie mat. So I have 3 data sets. So let's just do a certain operation on ratings. So ratings dot, I'm sorting the values, sort values, by number of ratings, and let's say ascending is equals to false. Okay, dot head. So I am sorting by the number of ratings. So these are the highest number of rated movies. Okay, these, so Star Wars, Contact, Fargo, Return, JD, and Liar Liar. So from that, let's take 2 movies. Okay, so Star Wars and Liar Liar. So these are different genre. Star Wars is a sci-fi, and Liar Liar, if you know, it is a comedy. Okay, so I have taken these 2 for example. So I want to see if someone is watching Star Wars, what other movies can we recommend him, or if someone is watching Liar Liar, what are the other movies we can recommend him. Okay, so that is our target. So let's see the Star Wars rating. Okay, so Star Wars, let's create a variable, Star Wars user rating. User rating is equals to, we will call movie mat, that is our the third data frame, that pivot table data frame we called, and from that we will call the column by movie. We see we have every column by the movie name, so we will call the column Star Wars. Okay, so let's just call it Star Wars, and let me just copy it here. So this is the movie name. Okay, let's again do the Liar Liar user rating. I am just extracting 2 examples. You can do it in any examples you want. So movie mat, from that I will be extracting Liar Liar column. Within quote. So now I have this thing. So let's see the Star Wars first. The Star Wars user rating. Okay, dot head. Let's see this. Star Wars. Oh, it's not Star Wars. But let me just make it here right. So as you can see, user 0 rated it as 5, user 1 rated it as 5, and user 3 didn't rated it. So it may have some nan values. Okay, if you just plot top 10, you may have more nan values. Oh no, as it is a very let's see 20. Let's see for 20. Now we see, because not every user rated Star Wars, it has some nan value. So what we will be doing, we will be dealing with those nan values. But before that, let's just bring the main hero or main function in our plot. So what we will be doing, we have this column. Now what we will be doing, we will correlate this column with every other column of this movie mat. So what we will be doing, we just extract one column of one movie, and now we will correlate this column with every other column of this movie mat. Okay, and we will see what is the correlation output. Okay, so that is the, if the correlation is high, that means the movie is rated same. Okay, it is if Star Wars is rated 5 by a user, maybe the user will rate another Star Wars movies as 5 also, because it is also sci-fi. If there is another sci-fi, the user is likely to rate that one is also, if it is a good Star Wars, good sci-fi movie. So that is how the correlation will increase. So we will see what is the correlation. So we will type similar to, let's say similar to Star Wars. Okay, that will be movie mat dot core with. So this is a function from pandas. So correlation, it finds a correlation of a particular data frame with another data frame. So which with which we try to correlate with. Now we have another thing, this Star Wars rating. So we have this thing, Star Wars rating, and we want to correlate with the movie mat. So I will pass correlate movie mat with Star Wars rating. Star Wars user rating, sorry, user rating. Okay, rating or ratings, what I see. Okay, rating. Now we can do similar thing with what is this? Is it? It is a runtime warning. Don't worry about that. We can do similar things with the layer light. So similar to layer is equals to the same thing, movie mat. We will correlate with movie mat, and we will pass the layer user rating column, layer. Okay, so let me just run it once, then run it here, then run it here. Okay, so we have now two other columns, two other variables which have the correlation variables. The correlation output of one is from Star Wars and one is for layer. So let's see what is the output, what did we get. So to do that, this is a panda series. Okay, so if you just type here, type similar to Star Wars. Similar to Star Wars. It is a panda series. So let's just first convert it into a data frame, so that for the ease of representation, so let's put it into a data frame called correlation core Star Wars. Okay, that is equals to pd dot data frame, and we called similar Star Wars, and let's just put the column name. Columns is equals to, let's say, correlation. Okay, so let's just do that, and let's see correlations core Star Wars dot head, how it looks like. Okay, as you can see, the Star Wars is correlated with till there was you as 0.07, 1-900, that is minus. So these are the correlation values of Star Wars with other titles or other movies. Okay, so if you see, let me just find if there is an let me just put it here. If I run 20, as you can see, there are some nan values, or it may have happened because the Star Wars movie has don't have any value, or this movie don't have any value, so the correlation becomes nan. So what we will be doing, we will be dropping those NAs. So core Star Wars dot drop NA, that is the function, and we will pass in place is equals to true. In place equals to true is to make these changes dropping. As I am dropping these values, this change will become permanent. Okay, so it's just passed n equals to true. Okay, so now we don't have any values. We are good to go. So let's just see. So what we can do, we can just sort those values. Let's see what are the highest correlated values, what are the similar to Star Wars movies. So let's just to do that, what we will be doing, we will be calling core, because we have those correlations Star Wars Star Wars code dot short values, and we will pass short values by correlation. Which column we want to short? Correlation, and we will pass ascending equals to false. Okay, and let's see the head of it. So now what we have now, as we can see, if someone liked Star Wars, or Star Wars, if Star Wars is rated as 5, they are likely to watch Man of the Year or Hollow Reed or Strips or Bean of the Egypt, but the problem here is, as you can see, these are none of our familiar movies, right? So what is happening here, and why these are exactly correlated? So correlation is 1, so they are saying it is exactly correlated. It may have happened like that user rated Star Wars as 5 and rated this movie as 5 also, but this movie has only that user only one rating it has got as 5, who also happens to rate Star Wars as 5. So it has got a very similar rating. So as you can see, so it may have happened that these movies may have got very few ratings because of what, the average value of the ratings is exactly same with Star Wars. That is why it is showing exact one correlation. So to walk around this problem, what we will need to do, we will need to see how many ratings it has. The correlation, where the correlation is high, how many ratings it has. Okay, so we need to do that also. So in that, so how we can do that? So we have this core dot stars. If I see here, core Star Wars dot head. So we have correlation with the title. If I have the num of ratings of this title, we can see how many ratings this particular movie has, and then if the rating is high, we can say okay, so these two movies are correlated. So I can have another column of num of movies. So num of movies, we have this column in which head, number of ratings, this. So ratings has the column number of ratings, so we will take this column from ratings and put it here in core underscore Star Wars. So how we will do that? So we will say core dot Star Wars is equals to core Star Wars dot join. So I will join it. What I will join? I will join the column number of ratings from ratings column. Is it number of rating or number of ratings? Number of ratings. Okay. So I will join this column with Star Wars. Okay. So that is another, and let's just then see how it looks like. Core. Okay, it is not core dot, it is underscore. Core underscore Star Wars dot head. Core Star Wars is not defined. Star Wars ratings. Yeah, now as you can see, this movie is very much correlated with Star Wars, but it has only 9 rating. So it is not significant to, it is not making much sense to consider this movie is highly correlated with Star Wars, because it has very less number of ratings. Similarly with this, but 101 Dalmatian 101 Dalmatians, it has 101 ratings, and the overall correlation goes low, it is 0.2. Similarly, 12 Angry Men has very less correlation, as it has high number of rating. So I need to see when the number of rating is high. In that case, if the correlation is high, then we can recommend that movie. So I need to put some threshold. So if my number of rating is higher than this much, so if I consider my number of rating is higher than, let's say 50 ratings, if it has at least 50 ratings, then I will consider that movie, that correlation. If it is not, then I will not consider that correlation. So let me just see here, we just plotted the number of ratings. So as you can see, the number of ratings is falling dramatically. Okay, so if I can take 50 or 60, maybe that will be fine, but you can always change the threshold and see what are the outcomings. For the timing, let's say 100. Okay, if the movie is having more than 100 ratings, then I will consider its correlation with our movie, my movie, that is I am finding similar finding for recommendation. Okay, so for that case, for now it is the Star Wars. Okay, So let's see, let's put the 100, the correlation is 100. So correlation CORR, Star Wars. I will pass the Star Wars, column name is number of ratings. Number of ratings should be greater than, number of ratings should be greater than 100. Then this is the value. So I have got some values which has more than 100 of ratings. Then I will sort values, sort those values from high to low. Oh sorry, sort values using the column correlation. Correlation. Okay, and then I will say ascending equals to false, and then I will see the head of it. So it is a huge line. Let me just break it down for you. So I am calling the Star Wars rating column, number of ratings column, and I have put it a condition if it is greater than 100. The number, if the number is greater than 100, then only. So those rows will be selected, and all those rows will be sorted using the value of correlation, and it is sorted as descending. Okay, so it will be given the highest value first and then the lowest. So if I just run this, now you can see the highest correlated value with Star Wars is the Star Wars title itself, because it is the same exact movie, so it is obvious to have correlation of 1. Then Empire Strike Back, that is also a Star Wars movie, if you know. Return of Jedi, that is also a Star Wars movie. Riders of the Lost Ark, it is a Indiana Jones movie, which maybe you may also like. Okay, so Austin Powers, I don't know which movie it is. It is let me just check. Let's just do Austin Powers. So it is a comedy, a spy. So it has a comedy movie. It is rated 7, IMDb 7. So it is also popular movie. So you can see another trend. If you happen to like a blockbuster movie, it may recommend you another blockbuster movie also, maybe in some other genre, but it is also, but as you can see, the correlation has gone severely low. So it has 0.377 correlation. It has 0.74 correlated with the Empire Strike Back, or Return of Jedi, it has 0.67. But when you go to the Indiana Jones movie, it has fallen down to 0.53, and for this one it has even fallen down to 0.37. Okay, so this is how the correlation, using those correlation, we can see what are the movies that I can recommend depending on which movie I just watched. So that is for Star Wars. Let's do this with Liar also. So for Liar we need to make another let's say correlation data frame, that is a correlation Liar. So what I will be doing, I will just call pd.data frame, and I will put that thing. So I will put this thing where we this similar to Liar movies. Okay, so similar to Liar movies, I will be, let me just copy it. It is a big name. Copy paste. Similar to Liar, and then I will create a column. Columns equals to correlation. same thing, correlation, and that's it. And then I will do correlation of layer dot drop NA if there is a drop, and if there is any nan values, and then just see. Dot head. So now it is drop. Oh, as you can see, I dropped the NA, but there is also showing the nan, because this change I didn't made it permanent. To make it permanent, I need to pass in place equals to true. So now if I run it, those NA, the change of dropping NA is made permanent. So in place equals to true, make this method result of this method permanent. So now the correlation, as you can see, these are the correlation with other movies with layer. Now we will be performing the same thing. We will be doing, let's say, correlation layer, and then we call it core layer, and we join it. Sorry, we need to join that now. Just a second. Core layer is equals to core layer dot join by ratings. From ratings data frame, I will be calling the number of ratings. Let me just do one thing here. Number of ratings. Okay. By joining this, let's now just see the core layer dot head. So now we have the correlation. You see the exact numbers of ratings, it is appended here also as a column. Now let's do the same condition. So core layer, and from there I will be calling. So let's just copy this. Let's just copy this entire thing and put it here, and let's just change it, core layer here, and run it. And boom, you get it. Layer has the correlation of 1. Batman Forever has a correlation of 0.51. Mask, which is also stars Jim Carrey, I guess. Layer also has Jim Carrey. Mask also has Jim Carrey. So there is a correlation. But because the number of rating is low, there is the correlation also got down. So it is expected, if you saw layer, you will like Batman Forever or Mask or Down Periscope, like that. Okay. Con Air, although the correlation is low, but still these are the top recommendations from the data we have. Okay, so this way you can recommend the movies. I hope you got the idea of how you find the movies, how you correlate with using only one function. We haven't used any machine learning algorithm or very tricky methods. We just used dot core with. This is the method. This is the key factor. This is the key function here, dot core width of pandas, using which we can make an entire recommendation system that can perform pretty good actually. If the data is good, if there is a number of ratings, large number of ratings provided with the data, you can come up with pretty good solution. Okay, so that is it. So this is the recommendation system we have built using this data set. Now I will switch to the YouTube streaming and see if there is any question. If we want to know movie rating for 3.5 and 4.5, yeah, we can do that. Let me just go back. So here we have the movie ratings also. This is my rating column. Where is my rating? This is my rating, right? So we have the title, we have the rating. Here we can pass the pass the condition. We are saying the movie rating that is greater than 2.5 or 3.5 and less than 4.5. All those movies will filter out. Like here we use correlation star, one number of ratings greater than 100. Instead of number of ratings, we will pass ratings, and we will pass greater than 3.5 and operation less than 4.5. With that we can get the ratings which has 3.5 to 4.5 rating. That I am assuming you want to target this area, right? So you can do that. We can do that passing the condition in the columns like we have done it here, right? I guess that answers your question. Any other question? Any other question from anyone else? I guess it is pretty simple and straightforward what we have used till now, but you can always go to the other file that I will be providing you at the end of this workshop, and see if you can connect with those linear algebra and all those methods for using the collaborative filtering. Okay, it will take you some time to understand if you don't have the background of strong linear algebra, or you are not coming from a mathematics background, but you can go through it and see if you can pull it off. If not, then this content based recommendation system also works pretty well in large scenario. Okay, so if you have versatile data, you can put content based recommendation system also, but you cannot just tally the user attitude or user behavior towards particular item, how this user is behaving with those item, and using that you can recommend another item. So that won't happen, but you can always recommend the similar kind of product to the user. Okay, so that is that, and I'm expecting any question if you have on content based recommender system. You can it is your time to ask, or otherwise there is half an hour left, so I will switch to decision tree, and we will have the decision tree also today. So if you have any question, you can please ask. I am seeing the chat on YouTube. I will also take a 1 minute break. Give you some time so that you can ask if you have any question, or otherwise I will switch to decision tree. Okay, seems like you don't have much of a question. That means you understood everything or you have understood nothing. Though two, both the possibilities are there. So I guess as it is a very simplified approach and I try to bring it to you in a simplistic mode, you have got the point. And let's move to decision tree now. So I will be switching to another notebook, and before that let's just have a discussion on what is decision tree and random forest in general. Okay, so let me just go to my, yeah. Let me add up another tree. Decision tree is algorithm which okay, let's just take an example that will be helpful to explain it better. Let's say I have a friend and I play cricket with him, and depending on the day, depending on the scenario of the day, the friend shows up or doesn't show up. Okay, so let's say I have three scenarios, like the outlook. If I say outlook, it can have or overcast or rain. Okay, so I have outlook, then I have humidity, then I have let's say windy or not, and then I have the whether he came or not, whether the friend came or not. So the outlook may have three categories: sunny, overcast and rain. The humidity may have very humid or less humid, and the windy may have another thing, that it is a windy day or not windy day. Depending on that, I can see whether my friend is showing up or not. So I can build a tree out of this observation. If I have, let's say 5 observation, so let's say sunny, overcast, sunny, windy, rainy. Okay, humidity is like let's say 0.45 or 45% or 60% or 20% or 90%. Okay, windy is yes, no, yes, no. Come say, did he show up? So let's say yes, no, no, like that. So depending on these attributes or these features, my friend may show or may not show up. Okay, so if I take this, let's say I am taking or not. So let's take that. Let's take outlook as my one of my feature, and it may have three outputs. It may have sunny, so let's say put S. It may have overcast, so let's say put O. It may be rainy outlook, it may raining outside. So depending on that, I can have observation. So if it is sunny, so how many sunnies are there? So let's say we have hundreds of sunnies. So if I am taking outlook here, then I have these things left. So now let's take humidity another here. So let's take humidity. So now if sunny is the outlook, now I will try to see what is the humidity. Now humidity may be divided at more than 75% humidity or less than 75% of humidity. Okay, and now I see if I take outlook and humidity, I can classify it like if it is sunny and humidity is less than 75, my friend shows up, so it is a yes. Let's say 2 yes are there. 2 times in this condition, sunny outlook and less than 75% of humidity, my friend showed up. And if it is sunny outlook but the humidity is greater than 75%, he didn't show up 2 times. And it happened one time that in spite of having a sunny and more than 70% humidity, he showed up. So I have, this is also outlook. If I say outlook is overcast, I say 4 out of 4 time. Let's say there are 4 observations, so 4 out of 4 time he showed up. So for overcast, he loves overcast outlook, so he shows up every time it is overcast to play cricket with me. And let's say if it is raining, let's say I take wind. Okay, so windy have two functions. Let's say yes or no. If it is windy, yes, then he didn't show up. If it is not windy, then he showed up. So he didn't show up, let's say 2 times he didn't show up when it is raining and it is also having a wind flowing, and he showed up 3 times when it is raining but there is no wind. So likewise I can put a connection. So this is called decision tree, and here we can say this, the first one, this is called root node. This is called root node. And these arrows, every arrow in a decision tree is called a split. So these are my split. So what is a split? Split is the number of variation we can have from a node. What is the root node? That is the first attribute we take to divide, to split the data in different branches. Okay, and what is this? This is the outcome. This is the outcome, this is the edge. Okay, so these are the, and these I mean these are the edges. This is one edge, this is one edge. Okay, so and these are the leaf node. Okay, these are the leaf node, the final output. This is the last node, the last where there is no splitting happening. These are called leaf nodes. So if we have root node at the top, we have leaf nodes at the bottom where there is no more separation, and we have splits depending on different conditions. Okay, so that is the idea of how decision tree looks like. Now let's just take one step further and let's see how we decide the root node, why we chose outlook, why we didn't choose humidity as the top root node, or why we took humidity after outlook. So there must be some kind of logic behind it. So how to choose the root node or the next split node, the next node for the splitting, further splitting, how do we choose that? To do that, we will take another example, a simplified example. Let's say we have a data x, y and z, x, y and z, and we have class depending on value of x, y, z. Okay, so we have, let's say 111 and the class is A. If the data is 110, the class is A. If the data is 001, the class is B. And if the data is 100, the class is also B. Let's say this is my data. I need to make a decision tree out of this data. Okay, now what we will do, if I just take y, let's say if y equals to 1, this is my split, this is my parameter condition, and if I take yes and no as split, if y equals to 1, it is A, y equals to 1, it is A, y equals to 1 not, it is B, y equals to not 1, it is B. So I can split it perfectly, right? So for y class A, this is A 2 times, this is B 2 times. Okay, similarly, if I take x, y, z, I have taken y, let's take all three, right? So now let's take so how to choose the first split. So let's take x, let's take y, and let's take z. For x, if x equals to 0 and x equals to 1, these are the two values we can have in x. So if x equals to 0, we have B. If x equals to 1, for 1 x equals to A, so we have A here. For x equals to 1, we have A here also. If x equals to not 1, 0, we have B. If x equals to 1, we also have B. So that is my first split as x. If we take y, y equals to 1, y equals to 0, let me just put y here. So y equals to 0, y equals to 1. So for y equals to 0, 1, it is A, then it is, if y equals to 0, it is B, right? Similarly, for z equals to 0 and z equals to 1. So it has, if z equals to 0 and z equals to 1 first, it is showing A. For z equals to 0 also, it is showing A. For z equals to 1, then it is showing B. For z equals to 0, it is showing B. So depending, so what actually the algorithm does, it takes all those features, this is x, y, z are my features, it takes all the features and it splits the tree, and out of this it calculates either entropy or information gain or it's a Gini impurity. These are three mathematical formula that helps us to decide which split is the best split. You can take either of them, okay, you can mention it, but Gini impurity is one of the mostly used formula or mostly used method to find the best split. Okay, so using Gini impurity, if the impurity is low, that means the split is high. Entropy is low, then that is the best split. If information is higher, then that is the best split. So depending on which algorithm you choose, that algorithm will calculate all the possible splits, and it will see in which split the information gain or this one of this thing is optimum. Okay, using that it will take that split. It will happen automatically, but just for your information, if you ever wonder how this is happening, is it just previous page? No. Okay, I removed it, I guess. So if you just wonder how the splitting and all those things is happening behind the scene, this is working. Okay, this is the behind the scene work. Entropy, information gain, and Gini impurity. And if I talk about random forest, now random forest is something like if you have a decision tree is very much, it is dependent on, it is very much variant. It has high variance, meaning let's say it has taken x as split, it may lead to some value, some output. If it takes y as another split, it may take some other value. and the output may vary widely depending on the split and the node it is taking. Okay, so decision tree has very high variance. To cover this up, what actually we come up with, we take one decision tree here, another dt1, dt2, dt3. Okay, and what we do, let's say we have 100 features. Okay, out of 100 features means this XYZ are the features here. Okay, in this data set XYZ were the feature. So likewise we have 100 features. In dt1 we take, let's say 70% of the features randomly, and we make a decision tree. In another one we take another 70%, again it is random, so this 70% and this 70 are different, similarly this 70 are different. So likewise we create the decision trees, and there are number of decision trees we just create, and then randomly, because it is selecting randomly, this is why it is called random forest. And also the number of observations you may take randomly. So let's say 80% of the total samples is taken. So we have features A, B, C, D. These are my features, and we have 1, 2, 3, 4, 5 ... n number of observation. So we will taking 80% of the observation randomly and 70% of the features. Let's just for example, these values you can change. So randomly selected, then also decision tree 2, these are also randomly selected, these are also randomly selected. So this random selection will, and the average output of all these decision tree combined, so the combined average output of all those decision trees, let's say we have like 50 such decision trees, dt50 up to dt50. So all those combined output will give the random forest output. This is my random forest output, and this output will take care of the variance. It will reduce the variance of decision tree. Okay, so this is why random forest in most of the cases performs better than a single decision tree. Okay, there is another concept called bagged decision tree. If you may have heard bagged decision tree, and bagged decision tree is very much similar to random forest, but there is no randomness. So we take decision tree 1, decision tree 2, decision tree 3, and we for different cases, and then we bag it together. Okay, so it will be randomly selecting from all the samples, it will be, and all the features it will be training differently, and most likely the branches will be different for different selection. So, and the overall average output is called bagged decision tree. Okay, but bagged decision tree doesn't take care of a very dominant features. If it has a very dominant feature in bagged random decision tree, first root split will be taken by that dominant feature only. So then the other split will also follow more or less similar. So there will be not much of a variety of those decision trees. So to avoid those things, randomness is being added. The randomness is being added to get rid of any dominant feature, if at all present in a data set. Okay, so I guess the idea of decision tree is pretty much clear. Now we can go to our here, if I have it here, let's see, decision tree. Yeah, so as the time is less, it is only 15 minutes left, I won't be typing, I will just go through it. Okay, so the first lines are the mainly the imports. So these are my imports, so let's just import it. Okay, so I have imported all the data, and now let me just scroll down a bit. I am getting the data. This is kyphosis data. This is a medical condition. It happens in your vertical cortex. Sorry, the spine. The spine. Okay, it may be cured by the operation. So this is the data, and this is the head of the data. Okay, so if you plot it, the kyphosis is absent or present after an operation, and the information we have, the features is the age of the patient, number, and start. This is what is the number of the spine. I mean, the spine is built up with parts, no, something like that it is called. So which number of vertebrae is affected due to kyphosis, and the start maybe means something. So anyways, you don't need to know very detail about the kyphosis on the medical conditions. Okay, so let's do some correlation, pair plot. Okay, as we have very little amount of data, we can always plot. So these are the pair plot. Okay, so this is age versus age. Okay, start, and these are the pairwise plotting. Okay, number and start point. What is the number and what is the starting point? So let's just trend test split, do the trend test split, and for X I am dropping the kyphosis. So I want to predict, or I want to see, classify whether the person has kyphosis or not, depending on the age, number, and start. Okay, so I am just dropping that column, kyphosis column, which says absent or present, and put it in X as my features, and I am taking only the kyphosis column, absent and present, as my Y, which is my target column. Okay, and then I am doing the test trend split for my training. So decision tree, as you can see from scikit-learn.tree module, it has a decision tree classifier, so I'm importing that. Then ID tree is the object I'm creating to put all the functionalities of decision tree classifier. Then I am just fitting the decision tree with the training values. So it has been fitted. Now the prediction and evaluation. So this prediction variable will have all the predicted output predicted on the X test value, and then I will import the classification report and confusion matrix. Okay, so this part, this prediction and evaluation and training part is almost same for every classifier you do. What is different is here, you call up the decision tree, and I haven't changed anything in decision tree, although you have a huge number of hyperparameter you can tune, like say criteria, what is the criteria for selection, what is the splitter, max depth, minimum sample split, minimum sample leave, minimum weight, maximum feature. So there are many things you can tweak in order to improve the performance of a decision tree classifier. But as we just introduced and we didn't consider all the features and how this algorithm works, I am not tweaking any parameters. I'm just showing you how to build the tree and see the output. If you want to know, go into depth, you can always follow some blogs and or do some courses and go in depth knowledge of each algorithms and tweaking those values. Okay, or you can just see what are the values and see. You can do another thing that is called reverse engineering. As you know, you see this thing, what is the criteria in decision tree classifier, you can always search for it. What is the split, what splitter means, how to what are the splitters we have, what are the criteria we have, what criteria means what. Okay, So criteria can be Gini, can be entropy, can be the information gained, as I told you. So these are the things you can learn from here also. You take the keyword, you search for it, and you get the required knowledge of it. Okay, anyways, moving ahead, the classification report and confusion matrix we imported, and let's just print. So this is the accuracy. This is pretty bad classifier, 0.68 accurate. So we don't want this classifier to be actually used in any medical situation. There will be a massacre. So let's just print the confusion matrix. It is very pretty low data. We have pretty less data, as you can see, 8, 10 and 15, 25 samples we have for predictions. Okay, so very less data. Because of this also, this classification affected. Tree visualization you can also do. I am not doing it here because PyDot is another library that you need to install it separately, like pip install PyDot. It is not inbuilt in Python, and you can always check this visualization how it is doing. I am not going into much details of this, because most of the time you won't be visualizing a tree, you are concerned with the output of the tree. Okay, so but if any case you want to see how it is done, it is given here. I will provide you the code, and you can find it out yourself. Okay, so as it is not much of an important and we are running out of time a bit, so let's skip to the random forest. Okay, so we have it in ensemble module of scikit-learn. So we from that we go random forest classifier, RFC, random, that stands for random forest classifier short form. We create an object of named RFC, and we put random forest classifier. N estimators means how many number of trees we want to use. Okay, and we said 100. That is an essential. You need to pass an estimator, or otherwise it may take 50 by default. You can always press shift tab and see what other parameters you can use as random classifier. So here also a number of things you can use, n estimators and criteria and all those stuff, and those random state verbose and all those things. So you go ahead and see what each thing's maximum feature, how many features you want to take, how many samples you want to take, all those stuff. Okay, so go ahead, check all the hyperparameters and see what they means, and once you are done with that, you pass all those parameters and you just create the object, and you then just fit the object with your training samples. So it is fitted. Now we want to predict. Now you pass the x underscore test as predict, and then we print the confusion matrix here also. And let's see the what is the classification report. You see the random forest without doing anything. We haven't done anything with decision tree here, and it was giving 68% accuracy. And in case of random forest, we took 100 such trees and put it together, and we predicted it, and it is giving 80% without tweaking any hyperparameter, without doing anything. We just increased 12% of performance. That is a huge increment, huge in terms of a data set, in terms of industry. It is a huge increment. So as the data is little, the random tree, and most of the cases random forest will perform better than decision tree. Okay, so if we tweak the hyperparameters, it may give far better result than this also, 80% also. Okay, anyways, you get the idea. You get to know how to call and train using a random forest and decision tree. That is the whole idea of random forest also. So I will share this also with you, and hopefully you have got all the concepts discussed today. And if you have any question now, you may ask. So if there is any question. I guess no more question is also there, so we can, if there is no question. Oh, seems like I forgot to switch my window. Okay, let me just go through another time briefly because I forgot to switch my window. So this is the libraries. These are the data. Kyphosis data and data analysis. A bit of pair plot we have done, and then the train test split part from scikit-learn. We dropped the kyphosis for a feature, and we take only kyphosis for our target set, and then we called decision tree classifier, and then we train the classifier, and then we do the prediction by creating decision tree dot predict, and then we do the classification report and confusion matrix. We plotted it. These are the classification report. The accuracy is 68%, as I said you earlier, but you couldn't see it, and the confusion matrix is this. And then there is a decision tree visualization tool. If you want to use it, you can use it. Go ahead and see how this is being done. And then we came to random forest. We call random forest from the ensemble module, and we passed 100 decision tree, and we trained it with our xtrain and ytrain, and we predicted that random forest, and we see there is a very good increment of from 68 to 80% in accuracy, and same with precision and recall also. Okay, so that is the entire thing we done. I forgot to switch my window. Sorry for that. Now if you have any question, I encourage you to go through the .ipnyv file, the Python files, and see if you understand it correctly, fully, and if you have any question, you can always get back to me. Okay, and if you have any question for recommendation system also, you can ask it now. I guess there is no question as such, so maybe we wrap it up. Tomorrow we will be discussing natural language processing, and with that, let's close this session for today and see you tomorrow. Thank you.